pull on numbers there. So any burning questions just before we start? Great. So what we'll do, the idea for the session is for it to be as sort of collaborative as possible. I think while we're going to do some presenting stuff at the beginning, if you're not speaking, it'd probably be easiest if you put your microphone on mute. If you are asking a question, you want to interrupt from the floor. If you turn your video on, you can turn your video on, then that lets us know that you want to speak or raise your hand. And please just interrupt at any time. So the aim is to have plenty of time towards the end for questions as well as we go. And then we'll provide some information towards the end about some contact information for follow-up questions or anything else that we need to do. So what I'm going to do is I'm going to share my screen and make sure that is running. So Charlie, I'm going to rely on you to tell me that that's all sensible and visible. Yeah, brilliant. Okay. The bulk of this presentation is going to be from Charlie, so I'm just going to do a little bit of talking at the head of this. Welcome to this workshop. Thank you for taking time out of your day to come and join us. I hope this is going to be interesting and useful for you. Thank you for the organisers at ICAMPAM for setting this up and giving us this opportunity. So the aim of the workshop is for it to be a practical session. We want to get people up and running, analysing GENEActiv in R. It's also a forum for more experienced users of R and GENEActiv data to ask questions of us and of the community. So please don't be afraid to ask other people. If we facilitate a useful discussion amongst the members of the workshop, that's more useful than us being on send. Because I can see within some of the names that there are some more experienced users here. So don't be afraid to give people the benefit of your experience in this space as well. So the objective for us is to leave you with some new resources, some knowledge, and some connections out of the workshop as well. As I said, I'm going to do a little bit of talking, but in the presentation that Charlie is going to give directly after this, or the workshop, there are a couple of links and a couple of areas that he's going to work through. So what I've just done is I put this slide up here now with those links in, and Charlie is going to paste those into the Zoom chat. So that if you want to follow along and look at the tools running as Charlie's running them, and you don't have these on your system, then you can go ahead and get those downloading while I'm talking, and it'll be more useful doing that than listening to me, I'm sure. So the first two are just external public links that most people will know, and the last one is one on our website, and you'll see that there's a little permission box comes up so that your email address comes in. We just use that so that we can provide notification of updates. It's not used for anything else. And then the other thing, if you did want to do a little bit of analysis, if you've got some bin file data for a GENEActiv, if you have it lying around, then you could probably have a play with that whilst Charlie's talking. So just for that last slide was obviously for people who are somewhat familiar with the GENEActiv, just a single slide on Active Insights for those people who may be less familiar with what we do. We're a business that specializes in the continuous measurement of human behavior. We've got a unique mix of technology, services, and expertise that helps us do this and helps us to do this for our clients. And our client base is largely in academic research, public health, and within the clinical and clinical trials space. In our technology area, aside from some of the data infrastructure, which would be a topic for another call, there are two main products that you'll see. And this conversation is centered really around the GENEActiv as a raw data accelerometer. The Active Insights band outputs slightly more processed data. It has some algorithms on board, which allows it to run for up to a year. But you'll see as we go through the presentation that the event output that it creates is compatible with some of the later stages of the work that Charlie is going to show you. So we support open source algorithm development in R. We manage 3 CRAN packages at the moment to help with raw data manipulation and analysis. Those are the 3 packages there: GeneRead, GENEActiv and GENEAsphere. It gives you, I put the number of downloads there, so it gives you an idea about the sorts of usage of those. So the GeneRead package would be very commonly used for people who are writing their own algorithms as well as running some of the code that we provide. And that just allows you to pull data into the environment. GeneActiv, there are some tools in here for doing segmenting data and applying models to that data. And lastly is a GeneAsphere package, which allows the manipulation of data for some forms of visualization, and particularly around the sedentary sphere. Separately to that, and I showed you the link earlier, we provide markdowns, and so that's basically a recipe that runs in R. And that the markdowns pick up the base functionality, which are in GeneRead and GeneActiv within your local R environment, and package that up in such a way to give you data reports. And there are additional functions in there. And so those markdowns we relaunched about a year ago, and there are a couple of hundred downloads of that over the last 12 months. So not as widely used, but actually increasing very quickly as more sections of that become validated. I'm just going to take one little bit of a deep dive into the data, and because this will come up a couple of times, and talk about event coding. So within the GeneActiv code, and therefore within the markdowns that Charlie's going to show you, we use a process.
But it combusted.
Was that an intentional interruption?
This is to be off, eh?
I'm going to carry on. If you do have a question, shout, but I think that's a bit of background noise. So we use within these code a process of change point detection to automatically identify transitions in the data. So rather than using a fixed epoch approach, which you'll see in many packages, we try to use a data-driven approach that allows us to represent the structure of the data as closely as possible. So what we do is we create, rather than a fixed epoch event of say 5 seconds or 30 seconds, we allow our segments to grow or shrink so that we are creating homogeneous blocks of data in a continuous fashion. And that is core to our approach. Now, it does make certain things more tricky, but one of the great things is it allows us to recognize bouts of behavior actually driven from the data, rather than having to post-rationalize those by either splitting or connecting epochs. So that's me. I'm going to hand over to Charlie now. So the session he's going to take you through is one that we use for quite generally within the training of markdowns and getting people up to speed with that. It normally takes around 20 minutes, which should leave us plenty of time for questions and discussion. So I'm going to stop sharing, Charlie, and hand over to you.
Cool. Awesome. So I'm just going to start by following through on the links that Joss put up on the screen, just so that everybody has confidence when they land on here that they're in the right place. So this is the window for downloading R. If you download it for the first time, you just need to click this link and it will come up and show you that you've downloaded R. So once you've installed that, you go to RStudio, you'll see this page. You just want to click the download, the free version, the RStudio desktop. That's going to lead you to something that's going to detect your system. If this isn't right, then there's some other options down here. So once you've downloaded those, you can go to the Active Insights website. If you navigate your way to the downloads and software, we're looking for the software tab, not the documentation tab. And then if you type in your email address here, this here should reveal, and let's give it 1 second, a link here for downloading Markdown tools. If you click on this here, it should download. I'm just going to delete that one there. Once you've downloaded the markdowns, you want to extract the folders from the compressed form. And inside here, you're going to have a sleep report and an activity report. The difference between the two is that one segments from 3 p.m. to 3 p.m. when we're concentrating on the nighttime, on the sleep part of the data, and the other from 3 a.m. to 3 a.m. when we're concentrating on activity. the way that you operate these, I've already set one up in here, is to copy a bin file. So this is some of Joss's data. The GENEActiv bin files are from the PC software, and it should look something like this. First 100 lines are header data, and then you've got the below. You want to copy that there into your, we'll start with the sleep report, into your data folder in the sleep markdown. So this here is how the sleep report should come out when you extract it from the downloaded file. You want to look for the rproject or .rproj folder file, and if you double click on this, you'll get an option about which program to open it with. You want to select RStudio. So double click that. In here, there is an Active Insights R Markdown tutorial. All of these steps I'm talking you through now will be found in that. So here we go. This here, when you first open it, it will look like this. You would want to go to sleep_multifile.rmd. Now this is essentially the control center for running the markdowns. When you're in here, if you've dropped your bin files into the data folder, you can just press knit and this will run through and run the analysis for you. Just to talk you through what it's doing, this first chunk of code is to set up the environment. The second is to, whether you want to time it or rerun. These are mainly for manual running of the markdowns. The next step is to install the correct libraries that we use and the correct version of GeneRead and GeneClassify. After that, we pull in each of the functions in the function folder. Now, the markdowns run through each of these functions chronologically, from number 1 up to 10. And that, so we check that the folders have been set up correctly, where we've got data, outputs, and the gene classification folder. We then find the bin files that are inside the data folder, so you can run multiple bin files, not just one. You can run up to 100 or more. It then picks up each of these files and it calls in the sleep report. So each file is run through the sleep report to generate a unique word output, as well as some outputs that it creates along the way. If I go to the sleep report, in here again, we have the environment being set up and some parameters being passed through from the top level. We then set up the parameters that we want. This here is for running the markdown. We then go down through. So we've done number 1 in the sleep multifile, the top level. The first step is to combine or segment data. So we segment day by day, and then we combine them all into an event data or data frame. We then decide on a naming protocol for the outputs. We create a post, current, and prior data frame for our classification. If you're looking for where we detect different behaviors, this is all found in number 4. In the activity report, you can see the cut points for our vigorous, moderate, light, and sedentary activity. The number of days in the file, the bed and rise detection, so how we do our sleep analysis. And then these from 7 down to 10 are the outputs, which I'll explain to you in the word report. So if I go back to sleep multifile, if I press knit, I've already, I ran this earlier just to prepare it, and it will come out with the output straight away. But this sometimes, if you haven't segmented the data, it can take up to 15 minutes per file. If you have segmented it, as you can see, it's very fast. So there's a top layer word report, which is a sleep multifile. This will contain a summary of all of the sleep files or all of the bin files that you've analyzed. So if you have 10 bin files, this will be the summary table produced for each one. If we go into the outputs folder, we have 3 different kinds of outputs here. The first one is an all data frame. So this is the event-based data, where we're taking the raw data, use change point detection to detect the changes in behavior, and then we've created some features based on each of the events. So to begin with, we'll start with this. So up, down, 90 degrees is up on your wrist, minus 90 is pointing down. Degrees rotation goes from 0 to 360. And I'll show you a plot in a moment that will explain a bit clearer. On each segment, we're looking to create a summary statistic. So over the 20-second epoch, we're looking for the median position of the up-down, so that you can see here the wrist is pointing downwards. We also calculate the magnitude mean. In the activity markdown, we use this for the classification of moderate, vigorous, light and sedentary activity. We have a temperature, we have a step counter, which Josh Waits has a poster about as well at ICAMPAM. And then we have a principal frequency detection as well. So this here is all of the data that has been processed from the files and the events that have been created from it. If I then take us to the actual report, so each bin file that you analyze, there'll be a markdown report generated. This here is the initial 48-hour daily view. So this is an up-down MAD plot, which is mean absolute deviation for every single segment. So if I go back to here, we have up-down MAD somewhere. This here, this column here is a column that we're plotting on this plot. The red lines are the bed and rise times. That was calculated by the bed and rise times. And we look at a 48-hour view, so from midnight to midnight over 2 days, so that we can see in a nice sort of straight line the sleeping pattern of the individual that we're looking at. The next plot is a daily plot, because we do this for every day that we've analyzed. This is where I was discussing the up-down degrees rotation arm position. So -90 is the arm down, 90 is the arm up. And so you can see the different posture changes and when we've detected the bed and rise. You've got counterclockwise and clockwise and wrist rotation. Then you have a temperature and light plot. And finally, we have our classification of each of those events. So we generate this for every day. And you can see when we've got the person actually, the individual is asleep. So we do this for every day that we analyze. And if we come down, we've got a daily summary, which gives us some summary statistics. Now for the sleep markdown, we're looking at sleep onset time, rise time, total elapsed bedtime, total sleep time, total wake time, sleep efficiency, number of active periods, medium activity length. The final page on the Word report is just the device details. This information has been generated from the top 100 lines of bin file. This is the information that you would type into the PC software. We also create a summary, sleep summary metrics output, which is the table found inside the markdown. So I can just show you from here. The sleep summary metrics here, the daily summaries. We generate that as a CSV as well. So you've got night starting, sleep onset, rise time. Here we have it as seconds rather than giving it an hour minute format. Okay, so that there is a sleep markdown. I would just come to the second one, the activity markdown. Again, we're opening it up in the R project file. Should bring it to here. Again, if you're opening this for the first time, your view should look like this. You're going to select the activity underscore multifile.rmd, and then you're going to select next. I've already processed this file, so it should give me some outputs rather quickly. Yeah, so again, for each file on the top level, you're going to get a summary table, giving it out in seconds. And for each file, you're going to get an activity, the all data frame again. This time, so the sleep summary, activity summary, and activity report. There are some differences in the activity report. First of all, there's no up-down MAD plot, and the times start at 3 AM to 3 AM. You can also see that we have some additional classifications here: vigorous, moderate, light, and sedentary. As you go down through, if I just scroll all the way down to the activity daily summary, we also have steps, the step counts, non-wear, sleep, sedentary, light, moderate, vigorous. So that's a major difference from the activity to sleep report. The CSV output replicates this as well. If I just select onto here, you will see that this here is in seconds as well. Cool. I think that is an overview of how to run the markdowns. Do we have any questions?
Charlie, this is naughty because we didn't talk about this question beforehand, but in terms of the bed and rise time detection, what you've shown us there is an automatic detection, output from an automatic detection algorithm, which I welcome other people to ask questions about. What about if I've got a sleep diary? So if I've actually asked my participant to keep a diary.
Sure. So inside our sleep diary, we've got inside the sleep markdown, sorry, we've got some functionality to incorporate a sleep diary. The way that we do this is we ask somebody to type in the file name that we're analyzing, enter in the night of date that we're looking at and the day number, and then you can enter in your sleep diary times of the sleep onset or the end of sleep time. We have to specify whether or not we're going to use the sleep diary by just entering a number into here. So if you're not going to use the sleep diary, you can just select NA and then the automatic detection will work instead. If you want to know more about the sleep and bed and rise times, how we actually calculate them, you're going to find them in function number 6. We classify SIN, which is sleep, inactive, and non-wear. And we use a SIN score to work out the most likely position of the bed and rise times. And that's when we start. That gives us the area or a general idea of where the person's got into bed and got out of bed. And that's how we start looking for a bed and rise time. Cool.
Thank you.
Do we have any questions?
Yes. Hello?
Hi,
Hello
Jeff.
there. Hey, Jeff, how are you doing?
Good, how are you?
Yeah, I'm right, thank you.
Great, that's really interesting work. I'm just wondering if you could discuss a little bit about in which populations this was validated and how that process was done. Seems quite challenging to do, and I was just wondering if you could touch on that a little bit.
Yeah, I'll start answering the question, Jeff, and then give Charlie just have a little think about it. I think what we've got here is some open source code for the community to use and to work with, and we are in the process of validating sections of that as we go. Charlie, I think, can tell you a little bit about the sorts of populations that the basic structure was created around. I think to give you an idea about where we are in different places on this. So where we're outputting there some of the light, moderate, and vigorous threshold states in the activity markdown, that's using cut points which have been validated from other papers. And so throughout this work, where we are using information, we are referencing those papers the best we can. And one of the activities that we're going through at the moment is going through and making sure that the referencing is better and clearer. So where there is existing validation, we've used that. In other areas, we've worked in collaborations and to validate sections. And Charlie mentioned the step counter this morning, just now, which is on a poster by Josh Sweetland. I recommend you go and have a look at that. And that describes how that's been validated in a range of different populations, both in a younger, fitter population and in an older, more infirm population. And so Josh is presenting that validation at the conference today. In other areas, we've got ongoing work to validate aspects of the sleep diary and many others. And so where people have got an interest in collaborating and helping us to improve this code, then we look forward to those kind of interactions. I don't know, Charlie, if you can say anything particularly about the code, the sorts of data sets that we've used to get this to this point.
Yeah, so we use the Eislinger MSSEG 2011 paper for our activity cut points. You can find them in both the sleep and the activity markdown. All of our cut points are inside function number 4. So you can see that, Joss? Yeah, okay. Yeah, so from line 79 to 101, this here is from the, directly from that paper. All of our cut points are below this for our SYN states as well, so sleep, inactive, and non-wear. But this is something that we're working towards validating. We've got this paper set up. We will be taking the cut points from this paper. But in terms of our sleep and inactive and non-wear classification, you can find those cut points further down. Yeah, I think that's what I need to say.
Yeah, we've got 2 projects at the moment looking at non-wear and to validate those. What we found works quite well is we put up an algorithm that can be publicly referenced, that's accessible, and then we can work with researchers to validate and optimize those. And that's the process that I think we're keen to continue.
Thank you. Very helpful.
Josh, one of the questions in the chat was, is there any proposed analysis for chest or ankle data? And that was from Stylianos. And they also asked if it was from the wrist, and this analysis is just coming from the markdown from wrist-worn accelerometers for left or right wrist. This markdown can't be used at the moment for the chest or ankle.
I think, Charlie, I mean, to answer the question structurally, it's not a challenge to think about how to do that. I think the structure would lend itself very well to being able to use in different positions. There are different ways of including some models in there. I think it goes back to Jeff's point. One of the things, we see a lot of wrist-worn data, and we spend most of our time working with that. We don't have huge amounts of ankle or chest or back-worn data. But would be, if there's a group that's got data from a different location, we'd be very happy to collaborate and look about and help and support the modification of this code to do that. Equally, this is code that you can pick up and use. So as long as for the markdown code for non-commercial research, this is available for you to use. You're welcome to change it and move it, and as long as you cite it and reference it, it's there for other people to either modify or use as inspiration for their own analysis.
So any more questions? Have you compared, or are there any plans to compare the analysis tools with others published like GGIR? I'd say that the main difference between us and GGIR is a events-based analysis. Joss, do we have any studies on the comparison?
Yeah, so I think we wouldn't do the comparison between GGIR and our code. We work with Vincent. I work with Vincent on many projects, and he's done a great job over the years with the GGIR code. I think the nice way of working in this environment, in this community with open source code, is that this is another option. It's a different way of doing things. And there will be some functions within GGIR that are more developed. And there are some functions here which provide an alternative route. And as Charlie says, one of those is about the event-based work. There are a couple of good papers out there on event-based or variable length segment work. And some of the work that Joshua Thwaites published in his PhD demonstrated by using a variable length of data-driven epoch base rather than a fixed windows basis, you could get a better resolution on the data, or a better representation of the data, which within his machine learning models yielded greater accuracy. So I think there's more work that we can do there generally. But as I say, it's something that we would work with other researchers to do rather than validate ourselves.
Cool. I've got another message from Nick here. Have you compared your bout detection methods to other similar methods like Swan 3X for hip data? So you want?
So we've used a standard change point package, which we've optimized for in this person. Charlie can give you a little bit more data about the approach that we've used there. The Sojourn approach is very similar, and there are other change point approaches that have looked at, and the paper that I discussed earlier from Joshua, which I'll, in a moment when I've stopped talking, I'll go and dig out a reference for and put it into the chat, uses different change point methods. So I think just in the same way as we can look and do further research comparing to the Sojourn type and variable length approach to fixed epoch approaches, there is clearly the scope to be able to look at the effect of different types of change points. Certainly from the work that we've done working with the change point package in R, one of the critical things is to understand how you set up the change points, the penalties values you give that, the data streams that you use for the segmentation. And we spent a lot of time on the optimization for that. And I suspect there's as much, if not more, variability in the within a single approach based on the parameters you use to set it up, as there is variability between the different approaches.
Yeah, I think we spent a long time looking at those data streams that we can pull in to detect changes on, and try to understand how to use the various different ones, from mean and variance, just mean or variance. I think it's definitely something that we've done quite a lot of investigation in. But yeah, I think we've tried to optimize it to the best that we can, but we're looking to validate it and publish it in the coming months, right, Joss? Yeah. Cool. Do we have any more questions? One last question. Do you have any plans in the future to also create a Python package / tool? What do you think, Joss?
We've chosen over the years to work in R. The repository within CRAN is very helpful, and it does provide a standardized approach. We recognize that it's not necessarily always the fastest approach, and there are challenges with it. We know that many people will use Python within the space. Again, Joshua's works in Python, and there is some code out there in Python. I don't think that we would aim to reproduce this entire package in Python, but picking up certain elements of it. For example, we know that we've got change point elements that run in Python. We've got a step counter that we've done in Python. So in the step counter work, one of the things that we did was to implement the same algorithm in 2 different packages. So we've implemented that both in R and Python, and that's an interesting discipline to make sure you've coded it correctly. It's amazing how much you learn about your coding discipline by doing that. So I think different areas are worth pulling out in Python. I certainly, Charlie, wouldn't suggest that we spend our time trying to replicate R-based visualizations in Python. I think you take a radically different approach to that, but the creation of the underlying data should be the same. I think, ideally in all these areas, we're not using hugely complicated machine learning models here. So with data kind of embedded within the models, we're using relatively simple systems, heuristic-based systems, rule-based systems. A lot of those influenced by our experience of running machine learning, but they're all obviously highly deterministic. And really, you want to be able to show that anything that we can run in here in R, you can run and replicate in Python. So I think doing that on a module by module basis is something we are doing and will continue to do. But you probably would think differently about the visualization in Python for sure.
I think it's really good practice as well to replicate it in both R and Python. You really start to understand the intricacies of R and the differences it has to Python as well. But yeah, I think, like you said, Joss, we're creating module by module. Cool.
Yeah.
Okay. So any more questions?
Has anybody got, I'll open the floor more generally, anybody got other experiences that they've had with processing data and these sorts of techniques that they share, that got views that you think would be kind of useful in the community? It's an open floor. It's a unique opportunity to pitch a project. 10 minutes. Okay, that's great. So what I'll do is I'll just put a generic email that goes to our customer service. So the best email to get hold of both Charlie and myself is the info@activeinsights, if I can spell it right, .com email address, activeinsights.com there. So I think that works, yes. So if you've got any questions following on from this presentation, or you'd like to pick up a specific session, perhaps get some support on implementing some of these yourself, please just drop us a line and we'll reach out to you and get that set up. And there we go. Yes, I've seen that using Python might be easier with bigger files. Yeah, certainly memory management in R is something you've got to think quite carefully about. So its ability to use it. So we're well aware of that. So yes, Python definitely has its advantages. We're not blind to those. But yeah, so if you've got any questions or you'd like some further interaction, please just drop us a line. It'd be great to hear from you. We'll try to pull together a participants list from this call, and so we may send you an update in the next couple of weeks just to make sure that you've got all the links going forward. So, Charlie, anything else from your side?
No, I'm pretty happy with that. Yeah, like you said, any questions, fire away to info@activeinsights.com, and hopefully hear from you guys soon. So
thank you, everybody. I hope you have a great conference and that this was a useful start to the conference program. And I look forward to seeing some of you over the next 2 days. Thank you. We have got time left, so I'm just going to hang here anyway. So if people want to chat a little bit more widely in a smaller group, then just switch your camera on and switch your mic on and shout out. Thank you, Charlie. I'm glad the Dark Angel of demos managed to stay away.
Yeah, I think it went reasonably smoothly. Yeah, I think very, very handy to have it with all the outputs set up before.
It probably counts as cheating.
Yeah, it was an easier way.
How are all the people in the call?
Hi, just Charles. One more question. So since people are not coming to the floor, so we used a lot of GENEActivs since 2015, 13, maybe 14, 15. So I'm from Leiden University Medical Center. So we have a lot of devices lying down the last, let's say, 3-4 years. Probably most of them, when we tested it recently, are probably not working because of battery issues. So do you have any program of, I don't know, that we can send them back, or is it any possibility to at least make alive some of them somehow, or
yeah,
have you heard about these issues? Yeah.
Yeah, well, I mean, so the devices, I mean, any lithium polymer battery device, if left long periods of time, then has some challenges in terms of its battery condition, and they also suffer over prolonged usage. So once it's been cycled for a certain amount of time, the battery life decreases, and it decreases with time as well. We're always keen to help you keep those stocks as working in good condition as possible. So what I can do is just get the team to reach out with you, and we can then figure out how to audit through the stock that you've got and help you get that into working condition, and figure out how to make sure that you've got the devices that you need. I won't go into the details of that now, just given that this is a sort of a data analysis sort of forum, but we can pick that up with you directly, or you can email us.
Okay, perfect. We can contact you.
Yeah.
I'm sorry for the, yeah. Thank you.
No, it's fine. No, we're here to answer the question. It's great to have the question.
Yeah.
Just let us know. Then we'll see what we can do, work with you to make sure that you get the best out of the devices that you've got.
Yeah, and if you would like, because we developed not a lot, but some code, at least to open some files of GENEActiv with Python, and then we do some analysis with R. So we could also share with the community these scripts. That's something we can discuss.
Oh, that's great. So we've got some work actually that came, can't remember if it was from line in MATLAB as well. So we don't do a lot of MATLAB work, but we do have some code in MATLAB that people can use to read in GENEActiv data. It just means that it gets you over the first hurdle of taking that slightly strange data object and turning it into something useful in your environment. So yeah, that's brilliant to be able to share that. And if we've got permission from you to share that, we can put that up on our websites or on the forum.
Okay, thanks again for the nice overview.
No, well, I hope you're interested enough to have a go, and let us know how you get on.
Yes, I will. Yeah, thank you.
Brilliant. Thank you.
We've got one more question here. Do you plan to add some summary table for light exposure as you did for activity and sleep? I can actually, you could quite easily add that into the code. I can show you where. We don't have that at the moment, but you can definitely add it in. If you go down to the sleep summary, this here generates a sleep output. No, sorry, from bed rise. You can see we're just looking through the bed rise data frame. If you wanted to do some,
Thanks, Jeff.
got some drawing going on here. If you go down to where we calculate the seg data file, you're going to get all of your light readings from here, act data, or you can find the light readings in segment data here. And essentially, you would be looking at this, light.mean. So you could either collect data from the segments here, but we also plot the data out for each day, and we use the raw data to do that. Act data project. We can actually, you can look into the act data object, and you'll find the light recording for every, if it's 100 hertz, every 0.001 of a second, and you can probably create some sort of count there.
Yeah, it's the sort of thing, where we evolve the specification is based on people's what the needs are. And so if you've got a specific need in this area for a project, then talk to us, and there are modifications we can do that other people can benefit from as well. I think one of the challenges, if you're not working in a particular area, I don't know what sort of summary measure of light exposure is going to be, most useful. Some sort of aggregate measure of lux on a day, or time spent above a certain value, trying to look for indoor or outdoor conditions, or dark light conditions within the house. And that's the sort of range of sensitivity that makes sense. So I don't have the specification for that, but if you do, and you've got a research interest in that where we can put something in that makes a difference, come and talk to us. We're really always happy to see what we can learn from you and see how we can improve our tools to help you.
Yeah, I think that goes for anything in the summary table that you would want to calculate day by day. You can add it in if we've got it as a raw part of the raw data or part of the segment data. So if you wanted to look at temperature as well, then that's something else that you could add into that summary table. Like you said, Josh, it's just about creating the right specification, and then come talk to us, and we can try and help you.
We are just over our time, so I promised to close this session on time. So I'll say thank you again to everybody, and I look forward to seeing you over the next couple of days. Thank you very much, Charlie.
Yeah, thank you, Josh. Speak to you all soon.
Cheers. Bye-bye.
Bye-bye.